this module, you will learn about measurement of mass and time. Mass is the basic property of matter and a fundamental unit of measurement, since its measurement does not depend on any other physical quantity. The SI unit of mass is kilogram, denoted by small letters kg. We observe the standard kilogram weight used by different shopkeepers. But the prototype of the standard kilogram is supplied by the International Bureau of Weights and Measures, BIPM. The copies of the standard weight are available worldwide, including National Physical Laboratory in India for standardization of mass locally. If the magnitude of the mass of the object to be measured is much higher than the kilogram, say, for example, the mass of a paddy bag, unit like quintal, which is equivalent to 100 kilograms, is considered. Another higher unit is the ton, which is equivalent to 1000 kilograms. Masses of cargo containers are expressed in tons. Different types of balances are used to measure masses of objects of varying magnitudes. They range from electronic balances used in gold shops, common balances used in grocery shops, and platform balances used to weigh heavy articles such as reams of construction rods. However, some objects are either so large or so small that their mass cannot be measured using balances. For example, the mass of heavenly bodies, like planets and stars, or the mass of subatomic particles, like an electron or a proton, cannot be measured by direct usage of a balance. We employ indirect methods and techniques by which we can measure their masses. For example, the mass of heavenly objects can be estimated using Newton's universal law of gravitation, which you will learn later in the course. Mass of subatomic particles, like electrons, can be found by making use of devices like mass spectrograph. In a mass spectrograph, a stream of charged particles, like electrons, in rectilinear motion is subjected to electric and magnetic fields. Due to the effect of the fields, the particles then follow a curved path. Then the radius of the curved path of the particles, which is dependent on the mass of the particle, is observed. From the radius of the path observed, the mass of the particle is estimated. The usage of the unit kilogram is not convenient for measuring the masses of the particles like atoms or molecules. Hence, for measuring the masses of the particles like atoms or molecules, a convenient unit called Unified Atomic Mass Unit, referred to as AMU in short, was established. The symbol of Unified Atomic Mass Unit is U. One Unified Atomic Mass Unit is defined as mass of 1/12 the mass of an isolated atom of carbon-12 isotope, at rest and in its ground state, including the mass of the electrons. It is equivalent to 1.66 into 10 power minus 27 kilograms. The masses of different objects we come across in the universe have a huge variation. The table that follows shows the range and the order of the masses of different objects. Measurement of time is of utmost importance for us in our day-to-day life, and even in the history of science. Measuring time gives the chronological order of events that take place and helps in better conceptual and factual understanding of science. Measuring time is measuring the time interval between two events. For example, in a marathon race, the time interval between the instant of start of the race and the instant the winner crossing the finish mark is essential to declare a winner in the race. The ordinary watches, the devices that we normally look at to know time, do not help in deciding the winner, as the events of two persons crossing the finish mark can vary in a fraction of seconds. To increase the accuracy, we require the time measuring devices that can measure the smallest fraction of a second, the standard SI unit in measuring time. There were so many kinds of time measuring devices used in the past, ranging from the hourglasses, pendulums, sundials, etc., which measure time based on different phenomena. To have the most accuracy in measuring time, now we use an atomic standard of time, which is based on the periodic vibrations produced in a cesium atom. Hence, the clock is also referred to as the cesium clock or the atomic clock. In its cesium clock, the second is taken as the time needed for 9,192,631,770 vibrations of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom. The vibrations of the cesium atom regulate the time shown by this atomic clock, just as the vibrations of a balance wheel regulate the time shown by an ordinary wristwatch. The cesium atomic clock has an accuracy of 1 second in 1 million years, or an uncertainty of plus or minus 1 into 10 power minus 13. The number of seconds in a year is 3.1536 into 10 power 7. Hence, the atomic clocks lose or gain no more than 3 microseconds in 1 year. That is why a set cesium atomic clock is used at the National Physical Laboratory, NPL, New Delhi, to maintain the Indian standard of time. The time intervals of events that we come across in the universe vary over a very wide range. Some of the major time intervals are shown here in multiples of seconds. You have now reached the end of this module. In this module, you learned that mass is the basic property of matter and a fundamental unit of measurement, since its measurement does not depend on any other physical quantity. The SI unit of mass is kilogram, denoted by small letters kg. One unified atomic mass unit is defined as mass of 1/12 the mass of an isolated atom of carbon-12 isotope, at rest and in its ground state, including the mass of the electrons. It is equivalent to 1.66 into 10 power minus 27 kilograms. Measuring time is measuring the time interval between two events. To have the most accuracy in measuring time, an atomic standard of time is used, which is based on the periodic vibrations produced in its cesium atom.